Quantity information is an important and essential part of the cost estimate for a construction project. In this module, I will introduce the importance of quantity takeoff for construction and how quantity takeoff is carried out traditionally based on 2D drawings. Then we will discuss BIM-based quantity takeoff methods. Traditionally, quantity information is extracted from 2D CAD drawings. There are two major types of quantity information we need. The first one is information about number of building components or elements, such as doors, windows, columns, beams, etc. The second type is about dimension information of the building components, spaces, and shapes. For example, the sizes of a door, the area of a floor, the volume of a column, etc. Let us use screen snapshots of some video clips available on the internet as examples to demonstrate how quantity information can be extracted from the 2D drawings with the help of a computer software. As long as you can lay out a 2D drawing with correct scale and units, the software can help you to lay rectangles on top of the regions we would like to have their area values. Different colors are used to label regions for separate area quantity takeoffs. If we would like to know the number of windows, we just need to mark on the positions roughly where the windows are located on the drawing, and the software would count the number automatically for us. As shown in the figure, there are 9 windows on this drawing. With this traditional 2D quantity takeoff approach, we need to make sure we have a set of 2D drawings that contain complete information for quantity takeoff. Also, we need to be careful not to double count some quantity appearing in more than one 2D drawing. Because information in BIM model is in general more complete and consistent than that in a corresponding set of 2D drawings, BIM-based quantity takeoff should be more accurate than 2D quantity takeoff. As long as the objects are modeled in a BIM model, their quantity and dimensions can be easily calculated and queried. Unlike in 2D drawings, where an object may appear in more than one drawing, in a BIM model, all objects exist uniquely, so miscounting, including double counting, is unlikely. Furthermore, the quantity information organized in a schedule is linked in real time to the related objects in the BIM model. Whenever there are some changes in the model, the quantity information in the schedule is updated immediately. For example, if we delete a door in the BIM model, the quantity of doors shown in the schedule is reduced by 1 at the same time. There are 3 types of BIM-based quantity takeoff. The first one directly query quantity information for objects already modeled in the BIM model. For example, number of doors, area of a floor, etc. The second one derives quantity information from simple calculation using the quantity information that can be directly queried and other related parameters. For example, if we do not model rebars in the BIM model, but we like to estimate the quantity of rebars in weight, we can use the volume information of beams and columns with the values of their rebar ratios to calculate the weights of rebars for both beams and columns. For the third type, quantity takeoff is carried out through API programming. Because some information can be only extracted through API, and its associated calculation is much more complicated than just a simple formula. For example, how do we know the total painting area of a room if we do not model painting and add paint objects in the BIM model? We can calculate the total painting area by adding all surface areas of the columns, beams, walls, etc. within the room. However, extracting only partial surface area of a beam or column cannot be easily done without API programming. Another more complicated example is the quantity takeoff of the formwork without explicit modeling of the formwork in the BIM model.